تفضل دكتور عبد العزيز.
Okay, Assalamu alaikum جميعا. Welcome to the meeting with the chairman of Computer Engineering Department and the faculty of the department. Dr. Ayman Al-Milh, inshallah, the chairman of the Computer Engineering Department, will give you an overview about the Computer Engineering Department and the programs in the Computer Engineering Department. And then we will have an open discussion with Dr. Ayman and all the other faculty. We have here some faculties in the attendance. So if you have who are going, inshallah, to join our discussion. If you have any question, please either raise your hand or write it in the chat. Inshallah, I will read it after Dr. Ayman finishes his presentation. Dr. Ayman, the floor is yours.
بسم الله الرحمن الرحيم. والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. First, I would like to welcome you all for coming to this meeting with the chairman and computer engineering faculty. I would like to emphasize that the purpose of this meeting is more of really listening to you, our basically students, and answer your questions and hear your suggestions. For that reason, I just made a very brief presentation to just give you a brief overview about the programs that we offer in the computer engineering department. So I'm gonna basically talk about why study computer engineering, what really makes a computer engineer has an advantage over basically other engineering majors and so on. And then give a brief overview about the Bachelor of Science in Computer Engineering, what makes basically the foundations of this program. Then cover the concentration programs that we offer in the Computer Engineering Department, and also that are open to students who are majoring in computer engineering. And then briefly give some highlights about the graduate programs and what we are doing toward these programs, including the MX, and share with you a brief survey that we have done about with our alumni, basically highlighting what are the popular areas they are working currently in. So I always tell my students that really what's important about computer engineering is that it equips students with a strong foundation in all aspects that one needs in designing a digital system. So if you look at around us, like most of the systems around us are mostly digital, and they have like small components in analog. So you look at mobile phones, you look at computers, laptops. I mean, everything around us has actually an embedded microcontroller inside it that controls its operation. If you look at the car, you look at microwave, washing machine, and so on. And if you look at any system of such type, you will see that it's really composed of three main aspects that one needs to be aware or knowledgeable about. The first component or aspect is the software aspect. So any engineer really must have a strong foundation in basically software development so that he can deal with such systems. And if you look at computer engineering, you see that we equip students with a strong foundation in software development, starting with the ICS 104, covering like programming in Python and C, and then ICS 108, where you study Java. So you learn programming in Java and object-oriented programming paradigms. Then you take a third course, which is ICS 202, where you cover data structures and you learn about complexity of algorithms. You learn about some important data structures that you could use in implementing your algorithms, like linked list, trees, and so on. And then finally, operating system, which is very crucial to understand because any system is operated by an operating system, like the Windows, for example, or the Linux or iOS, where you need to understand how these operating systems work, because when you worry about, for example, the performance, the security of these systems, without such knowledge about operating systems, you wouldn't be able to understand a lot of the aspects. The second important element that our program basically focuses in is hardware foundation. So students need to understand the hardware foundation, the hardware design of any digital system. And if you look at the amount of knowledge that we actually equip students with, you see that basically it gives you a strong foundation in that aspect. Then the first course that students take is the digital logic, where they learn about the basics of logic gates and how they can be used to implement logic functions, like, for example, arithmetic operations like addition, subtraction, if I want to compare numbers, if I want like to basically design a traffic light controller, for example, a sequential circuit, a vending machine controller. So basically, the foundations that one needs to know in designing a digital logic circuit. And then the second course, foundation, which is very crucial and very important, is about computer organization and architecture. So now we know that computers are composed of a central processing unit. It has memory, and there are different types of memory, and how it performs the operations based on instructions and commands. So you really understand in this course the language of the computer, which we call the machine language or assembly language. So you learn how it's going to be programmed. You program it in its own language. Not only that, we show you how actually such like a computer or a CPU gets designed. How can we design it? Like given the commands or instruction set. So you learn how I can design one. In fact, at the end of the course, you design a simple CPU. Then we talk, like you learn in this course, okay, how can we make the computer performance better? What are the factors that impact the performance of computer? And like, for example, the concept of pipelining, and you learn about that. And then you learn about types of memory, like cached memory and the regular memory, and how it could help in improving the performance. A lot of aspects really. By this course, you really understand how the computer works. Then after that, you take a third course, which is about embedded systems. Now, we learn about like the CPU here and how it works and so on. In this course, now we said, like, as I said in the beginning, a lot of devices around us have an embedded microcontroller. We call it embedded system because, for example, a washing machine is not a computer, but it has a microcontroller embedded to control its operation. A car is not a computer, but it has a lot of like embedded microcontrollers to control its operation. So we call them embedded systems. So in this course, you learn about these embedded microcontrollers and how you could interface them with the real world, like sensors and actuators to measure things periodically in real time and so on. So this is a very important course actually that allows you to design basically such embedded systems where they can be of great benefit to users. Now, the fourth course is about design and modeling of digital systems. Basically, in this course, we teach you, okay, now how can you implement any software algorithm in hardware? And nowadays, this is actually very important because we need to do a lot of things in real time. And if we just write a software code and run it on a CPU, it may not achieve the performance desired in the right time that we want. So what can we do about this is that we accelerate that algorithm by implementing it in hardware so that it gives us like the real response that we want in the real time. Like if, for example, we have drones or automatic basically driving cars where they need to detect objects. So, I mean, in that case, we need hardware accelerators that implement the AI algorithms or the computer vision algorithms to detect things in real time and respond in real time. So all these courses are core that you take from computer engineering. Now, in addition to those, you need some like foundation course, in fact, that you need to take from electrical engineering department, which is about electronic circuits. So it covers the foundations about circuits and electronics. So if you look at this, you see that you really end up with a strong foundation in the hardware design aspects. And the third important element in this is the networking and security. So again, a system needs to talk with other systems, need to connect and transmit and receive data. And so in that case, we teach you 3 courses. The first course is called data communication, which is about the fundamental of communication, how we transmit signals, what is the bandwidth that we can transmit, the speed of transmission, the impact of noise, what type of transmission medias we can use, and all basically such fundamental aspects. If an error happens, how we can detect it and how we can deal with it and so on. The second course is about computer networks, and this shows you like how to design a network, how to connect it, like what are IP addresses, what are switches, routers, and how we can connect devices in a network, how we can analyze the network, and all aspects that one needs to know about like computer networking. And the third important course, which has become core in the new program, it used to be elective, which is the computer and network security. So the IEEE body of knowledge recommended that now this is or should be a core course for computer engineers. So you need to know about security. Today, as you know, cybersecurity is a very important element, and we need to know about it. And I believe that computer engineers are the best engineers positioned to deal with security, because a lot of attacks not only come from software, they come from hardware, from networking. So you need to be aware of all these aspects in order to be able to deal with these attacks and prevent their occurrence. And of course, the fourth element, which is common to all programs, which has been added to all undergraduate programs, which is knowledge about data science and artificial intelligence that you take with the ISE 291 and CUE 292. So these are basically strong additions to all the programs, where you learn about all the techniques, machine learning, for example, deep learning and classification techniques and data analytics that you need to do. And these are very important. As a computer engineer, you need, for example, when you deal with an embedded system, you need to analyze the data using some of these techniques and make decisions and so on. So I'm talking here about the core courses. I didn't talk about the electives. Now, once you end up with these courses, you'll see that you really have a strong foundation in all these aspects, which basically, as I said, composing a digital system. Now, after that, computer engineering students can specialize. Now, in the last year, in the senior year, they can choose to specialize in one of the areas. For example, computer networks or cybersecurity or Internet of Things or cloud computing or embedded systems, hardware design, and many others, as I'm going to talk about next. So if you look at our Bachelor of Science program in computer engineering, it has 128 credit hours. It offers both summer training and internship options. And I would like to emphasize here that the internship became 1 semester, 6 credit hours. In the old program, it used to be 9 credit hours with basically summer option. So you have to take the summer and a semester. Now, we have general education requirements, 22 credit hours like English, Islamic, and so on. We have math and science requirements, 32 credit hours about basically physics, chemistry, and math courses. And then the digital foundation, which is 12 credit hour, including the Python, the data science, and the artificial intelligence, and the business entrepreneurship course that all programs take. Then we have the core requirements, which are taken mostly from computer engineering and computer science, and 1 course from E, and these account for 47 credit hours. Then we have the CU electives, which are 4 courses, 12 credit hours, and the technical elective. Now, if a student chooses to go to a concentration, then he has to take only 1 CU elective, and the other 4 courses will come from the concentration. So this is in brief about the program. And I show you this flow chart, which is actually available in our website, which shows you in every year, with a color-coded information, what are the courses you take in every year. So you can see in freshman, you are mostly taking foundation courses and math and science courses, with the exception of the ICS 108, which is programming in Java, and ICS 104, which is programming in Python. Now, in the sophomore year, you start actually taking, taking courses in the major. So you complete the math foundation, but you can see you start with CO22, which is digital logic in the first semester with its lab. You start with the data science, and you basically continue the ICS data structure course. And then you take the data communication, the computer organization, and the digital system design here with the discrete structure here and so on. And then as you go on with the major, you start taking more courses in the major, computer networks, digital, this is digital system actually design. This was the AI course, and so on. So here we have the security course. And in the final year, this is where you choose to concentrate. This is for the summer training option. For the internship option, it is just 4 months. It's going to replace 1 semester. But this, as you can see, this squeezes the semester. So we recommend that now students, if you want to reduce the pressure on you, is that you take at least 1 summer, because you will be just taking 6 credit hours in a whole semester, while usually students take at least 14. So you will have pressure like in the other semester, but if you take a summer, you could reduce basically the load from the junior year or from the senior. Now, the computer engineering department actually, I believe that maybe it opens the most concentration programs that a student can enroll in. Like in our department, we offer 3 concentration programs, computer networking, Internet of Things. And this year, actually, we started the cloud computing, and alhamdulillah, it is launching, inshallah, in a successful manner. There was a high demand on it, and we had to restrict like the admission, but it seems, inshallah, it will have a good launch. Inshallah. We also open to our students concentrations from other departments, like the artificial intelligence and machine learning offered by the computer science department, cybersecurity and blockchain, where we offer actually one of the courses there, robotics and autonomous systems, quantum computing, where we also participate in it in one course, and data science. So our students can basically take any of these concentrations, any of these 8 concentrations. And the good thing about it is that you are ready, you don't need to take any course in order to enroll in any of these concentrations, with the exception of the robotics and autonomous system, where you have to take a course on control. And all the other 7, you don't have, like you satisfy all their requirements, so you can just like enroll in them without any issue. So these are about the concentrations. And here we have like a quick overview about each concentration, the ones that we are actually offering in the department. The computer networking, for example, we offer 4 courses, network design. So it gives you more in-depth knowledge about how to design networks. And we have, I think, Dr. Tariq, he can answer your questions about it. We have about wireless and mobile computing, cloud and edge computing, and network management and security. So it gives you more in-depth knowledge about the area in networking. If you look at the Internet of Things, we have a course which is called Introduction to Smart Systems. And this course actually was created to accommodate also students from other majors who do not have the background about embedded systems and so on. So it prepares all the students who join the Internet of Things to be ready and have the sufficient background to continue, like energy harvesting, interfacing with sensors and actuators, more knowledge about sensors and actuators. And again, Dr. Luai is leading this program, so he can answer additional questions. And then we have a course on Internet of Things fundamentals and industrial Internet of Things technology. And finally, big data analytics, because we are talking about IoT and edge computing. You need to do some big data analytics to analyze the data that you are getting at the edge and then making some decisions, and then the rest of data sending it to the cloud and so on. The third one, which is the new consideration that we are offering this semester, which is the cloud computing. And it has 4 courses, and we have Dr. Asais is basically leading this concentration. And we have 4 courses, principles of cloud-based systems. This is the first course. Second one, distributed systems and distributed computing. And the third course is about cloud and edge computing. And the fourth is cloud application engineering. So these are the 3 concentrations that we offer in the department. And I said we have also 5 other concentrations that are open for our students, and we participate in some of them by CU courses. For graduate programs, we offer actually a Master of Science in Computer Engineering, a Master of Science in Computer Networks, and Master of Engineering in Computer Networks, and PhD in Computer Engineering. In fact, we are actually working on revising our Master and PhD programs. And inshallah, by next year, we're going to start like the revised programs. We're trying to make them more flexible in terms of like core courses that students should take. So inshallah, once we approve them, we will start their launch. Now, as you know, the university has started 2 years ago what's known as professional master's program, where students after graduation, they can specialize in one of those professional master programs. And the intention is really to retrain the working force in the industry, so a student can come and specialize in one of those programs. We started them as 1-year program, but then it turned out that the intention was that students leave their work and come like spend 1 year and take their master and go back to their work, but it seems that this wasn't practical. Most of the students like who enrolled, they kept their job and they were taking like 4 courses in a semester. So we decided to change this to 2-year programs. So all these programs now, we offer actually 3 programs: computer networks, Internet of Things and embedded systems, and high performance and cloud computing. So these, starting from this year, all the 3 programs are 2-year programs, so that the student can take only 2 courses per semester. For the computer networks and the high performance and cloud computing, we opened them, the offering this year in what's known as Hive mode, where basically students can attend the classes in hybrid mode. So they attend 3 weeks of online classes, and then they come over the weekend to attend some in-person classes, do some activities and so on. So this is like a new launch of these programs. We hope that it will be successful, inshallah. Now, finally, I'm going to talk to you about a survey. We have done a 1.5 years ago a survey for our CU alumni and asked them several questions about how quickly they were able to find jobs and all these things. I think you can find the recording for this meeting. It should be in our YouTube channel. But here I'm just going to share with you one of the questions we asked them: what are the areas you are actually working in currently? And we listed some areas, and this was the response of our alumni. So as you can see, the majority are working in computer networks and also cybersecurity. Also, a large number of them are working as in software development. And you can see cloud computing. It's interesting. You can see that this is rising, and we have seen recently companies being established in the cloud. So this is going to increase like employment for our graduates, inshallah. Also, IoT is an emerging area, and we expect that more basically IoT development and more IoT employment to happen. And the other areas like web development, embedded systems, hardware design, high performance computing, and that side. So that gives you an idea about where the market is, or where our alumni actually are currently working. Now, these are the most popular computer engineering areas, and what a computer engineer could work as, like in computer networks, network engineer, network solutions architect, administrator, network analyst. And there I listed here some skills that one needs to know. Like you can see that most of these skills are actually met by the courses that we offer in the concentration where a student needs to specialize in one. Cybersecurity, again, cybersecurity engineer, information security analyst, network security engineer. And you can see the types of skills that a student needs to know. If you look at cloud computing, again, you'll see job titles like you can work as a cloud engineer, or cloud software engineer, or cloud application engineer, or cloud architect, or cloud system administrator. And there are lots of technologies that or skills that one needs to know. And in fact, all these are covered in our courses. I also would like to mention that once you take these courses, what I heard from Dr. Ra'is and so on, and Dr. Tariq, it will prepare you actually to get into the certificates, the international cloud certificates, so lots of certificates. So once you take and specialize in these concentrations, it will be very easy for you, because you will have the knowledge to go and pass these certificates and get them, which will help you in actually finding jobs, because these certificates sometimes are viewed as like additional skills that students have, or a proof of a skill that you have. And similarly for the IoT solution engineer, IoT platform architect, IoT developer, or solution architect. And finally, embedded systems, although this might not be a large market, however, we are seeing it increasing and it's emerging, and still lots of companies who are specialized in designing hardware and embedded systems would require embedded system engineers, especially in military applications, and small companies like emerging companies, where it has its own basically market where they can develop their own products and so on. So this is like the, I hope that I didn't take a lot of time. This is what I intended to present, and I think now we can listen to the questions.
Thank you, Dr. Ayman. I have just write down some questions. I also want to open the floor if you have any question. شباب إذا عندكم أسئلة بالعربي you can ask. تقدر تسأل بالعربي. بس إحنا we have to talk in English لأنه في عندنا شو اسمه بعض الحضور يعني ممكن ما يتكلم عربي. فإذا كان عندكم أي سؤال ممكن ترفعوا يدكم. If you have any question you can raise your hand and you can ask in Arabic or in English, and I or Dr. Ayman we can translate the question to English. Dr. Ayman, some of the students ask if they can get these slides. Are these slides available?
Sure, I can share them.
Okay, Dr. Ayman can share this question, these slides. طيب, there is a question about the positions for female and also about the PhD program. Is it going to be open for female students? And is there a GA and lecturer positions for females?
Yes, actually, as you know, we have started opening the female program, I think 1.5 years ago. And we got like the first batch of students who, most of them, I think, joined the computer networks program. But the university took the decision that, in fact, all our graduate programs, not only the computer engineering department, but all others, I think they are open for male and female. So students can join any of these programs that any department offers for males and females. And for undergraduate students, we, in fact, this year, we started admitting also female undergraduates. In terms of lecturer positions, definitely, we are looking for excellent candidates to join our department because, as you know, we need lecturers to help us teach the female students some of the courses, especially in labs. So definitely, if you're interested, just like send your resume and we will, or apply through KFBM job portal, and we'll do the necessary arrangements for interviewing.
Another question, Doctor. There is, I would call it like a narrative about COE is that computer engineering department, the program is all about hardware. Can you elaborate on this? Does COE students take programming, and do they have the good background to be software developers and compete with the ICS students in the market, for example, or computer science?
Do you still have, do you still have the same question after I went over this slide? Actually, what I want to say, okay, maybe we should emphasize here. We heard from some of the industrial advisory committee members that were in our department, in fact, from Aramco. He was a senior engineer from Aramco, and I think he led the cybersecurity. He said, we don't want like engineers who come to join the department to say, I am only network engineer, I can only do networking. They don't want this type of engineer. They want an engineer who can do multiple tasks. Like, for example, they want him to write a software program to enhance something he should be able to do. They want him to do network analysis, he should be able to do. They want him to do security analysis, he should be. So they want somebody who has all these skills, not just like, I'm just network engineer, or I'm just like security engineer. So if you look at computer engineering students, in fact, they can do software development. They have all the foundations, all the skills to enable them to do excellent software development. And I heard a comment from Aramco, and I keep repeating this, and maybe at least they said that computer engineering students were really excellent in software development. And the way we interpret it is that that maybe understanding hardware and how things work, it makes you a better like software developer than if you just like program. You don't understand what is beneath basically the system. So once you understand the system and how it works and hardware and so on, probably you will be able to write better software.
Okay, thank you.
It's a misconception. In fact, actually, it is a misconception that people think computer engineers are hardware designers. This is in the contrary. I showed you like what computer engineers work. Like the majority work in networking and security, IoT now, cloud computing, and you can see the concentrations we are offering. We're not offering a concentration on hardware design because simply we do not have enough market in the region for hardware design, although it's needed, but it's not like in the large quantity, like when we compare it to computer networking or cloud computing now or IoT. So we're focusing on the emerging areas now, which are these.
Okay. Another question asks about the relationship between high performance computing and cloud computing. And if you allow me, can I ask?
You're the best to answer this.
Okay. Yes. Thank you, Dr. Ayman. High performance computing, actually cloud computing could be considered like some sort of similar to the hardware high performance computing in terms of like the conception and the underlying hardware. Cloud computing is basically built on top of the idea of distributed computing, and distributed computing is a form of high performance computing. Also nowadays, high performance computing or high performance computing capabilities are offered on the cloud. Yani basically, most of the companies that uses the high performance computing hardware or capabilities, they use the cloud. And so in order to use the high performance computing, you might need actually to know how to utilize the cloud and how can you provision resources and how can you utilize how you can build your high performance computing system over the cloud. There is so many similarities on how can you design the software, how can you utilize these resources. So this is actually the relationship between high performance and cloud computing. Right. I don't see any hands, so I'll proceed with the questions that I have here. So there is a question about the networking CX and the CCNA. Will the networking CX actually prepare the students? I will generalize it. Will the networking CX prepare the students to acquire some professional certification in networking, including, for example, CCNA? Dr. Tariq is not here, I think.
طيب يعني احنا CCNA I believe is just like basic foundation. Maybe with the computer networking course that you take 344, you cover really what you need to get the CCNA. But I think that what we offer in the concentration is much more than the CCNA. So by taking CCNA, we actually offer the necessary training because you have to get trained on the Cisco technologies, like how to configure routers and switches and so on. And we actually have the Cisco Academy, and our lecturer, Mr. Hakim Adish, he provides the training, and students get it easily. So you should be able, as you know, we don't like teach technologies like CCNA in classes, but we teach you the fundamentals. Now it's very easy for you to go and see, okay, what additional technology-specific knowledge do I need to accumulate to get this certification? For example, I want to get a certificate on Google Cloud. You already have the foundations about all the Google technologies, so it should be easy for you to go and get Google Cloud certificate or Alibaba certificate. I saw somebody asking questions about collaboration with the companies, I think on cloud or so. Definitely, I mean, we will try to, in fact, we try to reach out to some of those, and definitely will join forces and try to see how we could collaborate with them so that we are always having, or what we offer is the state of the art, so that our students graduate ready for the market, not like graduate and still they need to like a lot of learning to be able to deliver to the market. So we will make sure that in these concentrations that our students are ready and they are really up to the requirements of the market.
Also, there is a question, Dr. Ayman, about the hardware design. What is the hardware design and what are the skills that needed in that field? And also, what are the courses that serves that in this area?
Yeah, for hardware design, as I said, if you want to work in hardware design, so what we offer you this digital logic, which allows you to design very simple logic systems like traffic light controller, for example, vending machine controller, like this arithmetic circuit. But then the second course, the design and modeling of digital system, this really goes more in depth. So you learn about a hardware description language. which is how you describe your design as a language and then give it to the tool to create for you the hardware and do the optimization. So you learn about optimization techniques, you learn about how you could actually create a design, like translate an algorithm to a hardware implementation of that algorithm, how to make it efficient. And with the electronic circuits, so all these are under hardware design. If you look at embedded systems, it can be considered also as under hardware design, where a company wants you to design an embedded system, for example, advanced electronic company to measure the power, design a power meter that can basically remotely measure the power consumption of houses. For example, I can design an embedded system to track the behavior of a bus or a driver, how he behaves, and develop an app to basically display the map and show certain information about his speed, how he acts in turns, and so on. So applications are a lot, like in this one, for example, in designing a robot, we're using AI. So all these can be considered under hardware. So in order to work in hardware design, you need electronic circuits, you need embedded systems, you need these two courses. But maybe if you are interested really to become a hardware design engineer, then your 4 major electives, you can take them now to specialize even more. We have more courses that we offer about hardware design, like how to design an ASIC, for example, application-specific integrated circuit. We have configurable computing. We have other courses that you might also take to enhance your knowledge about hardware design if you are interested to continue on this. But the foundation that you have also gives you the ability to really work as a hardware designer, like using field programmable gate arrays and so on. And then you can enhance your knowledge more in that area.
Okay, thank you, Dr. Ayman. There is a question about what are the fields, it's about the robotics. It says that what are the fields that the robotics will help the CU student in? And if a graduate would take a robotics CX, what are the fields that will help him, or how can we apply it, for example?
Now, if you want to specialize in robotics and autonomous system, do we have Dr. Baroudi?
No, I don't think. I think he's not here.
Yes, the robotics concentration is offered by the control and instrumentation engineering department. But basically, when you design a robot, you need to basically do path planning. You want the robot to do a task. So how he is able to choose the path. You need to program that robot. So they're you need to know about the programming language of robots, operating system used in robots, how to make robots communicate with each other to basically coordinate their tasks. You need computer vision to be able to perceive the environment and avoid obstacles and so on. So a lot of actually multidisciplinary areas are involved in robotics, like control, electrical engineering, computer engineering, computer science, mechanical engineering. So this is a multidisciplinary area. So there are lots of applications of robots, of course, autonomous systems where you can design robots to do a lot of automated work. So this is where, the applications that people can work, in designing robots, programming them, and so on, for doing this. In fact, many years back, we visited a factory about ceramic, I think a module, and they were using robots, to examine the ceramics. If they are defective, move them from one place to another. Look at companies like Amazon, Alibaba, how they serve their customers. They use a lot of robots to go and bring things from the store and put them, package them. And so a lot of things can be automated with high accuracy. Today, if you look at the medical field, robots can do operations with high precision. And so applications of robotics are tremendous.
Okay. There is a question, Doctor. Actually, it might take us to another area, which is about the employment. There is a question about some notable graduates from CU department. If you can also shed some light about the employment opportunities or some successful, just some highlights about the employment and the opportunities for.
Yeah, the thing is that when we look at when we did the employment survey, we found that most of our graduates are really or they didn't have any issue with employment. Very few of them got delayed, but then even those that were delayed ended up having very high salaries. We didn't find that computer engineering students are having issues with employment. Okay, so most of them really work. We're planning, inshallah, to do more recent survey about those who graduated within the past 5 years. But what we did, the survey we did 1.5 years was open for all our alumni. So it was mixed with the responses from those who graduated 20 years back, 15 years, 10 years. So it was like mixed. But we
Dr. Ayman, you were muted.
المعذرة دكتور أيمن.
Somebody okay. For example, when we look at the statistics that were done in the major selection day, we have always come among the top like 2 in terms of demand. Like last year, the year before. So the companies are asked like which major do you want to hire and so on. So computer engineering was selected among, I recall, among the top 2 in the last 3 years. So I don't think that there's an issue with employment. Like, I think other majors have more issues than computer engineering. First, also, if you look at the number of graduates in our department, we do not have a large body of students. تقريبا, we are around like 250 to 280, like so the number of graduates are not high, like in other departments. So competition is not high. So our students find jobs easily. Of course, finding a job depends on you, student, and we always advise our students how to work on your skills, extracurricular activities to help you find jobs. Because I mean, if you don't work on yourself and develop yourself, it could not be the issue with the major. It could be the issue with you, that you don't have the skills needed by the industry, and that could delay your employment. Like in بصفة عامة, I believe all KFBM graduates shouldn't have a problem really in employment, no matter what major you are in. In fact, companies often look for computer engineers, I mean, KFBM graduates in general, and they would like to hire them because they know what KFBM is and they know our standard. And we know that if you graduate from KFBM, it wasn't easy, and that you are really worth it and you have the necessary skills to succeed in the market. And I mean, the market, if you look around us, most of the leaders around us are KFBM graduates.
Thank you, Dr. Ayman. I may also add to your comment. Personally, I know 3 students who got offers before they graduated. Before they finished their degrees, one of them got an offer 1 year before, while he was in a junior. After he finished the junior, he did his training. And during his training, he was offered a job, and the company told him that they are willing to wait 1 year until he finished the requirement before he he joined the company. So I'm talking about something over the last 4 or 5 years. I know 4 years, the last 4 years. I know 3 cases where students were hired even before they finish their degrees. I think there is a demand in the market, and there is
Actually, we have so many successful stories. COE alumni, we have many of them who are really successful. Chief executive technical officers in HPE, for example, in IBM, and we have lots of like COE graduates, alumni, and inshallah we'll try to invite some of them. We invited like some last year. We'll try to invite more and let them talk to you.
Yes. Okay. Okay. There is a tricky question here, Dr. Ayman. Some students are asking about the COE and ICS, how they are different from each other, and also is the ICS degree is stronger, COE degree is stronger. So can you tell us what is the difference between, or tell the students what is the difference?
This is a very good question, actually. In fact, an excellent question. If we look at actually computer engineering programs and computer science program, the current programs that we have, we will see a big overlap, in fact. And okay, what's the difference? I'll tell you the difference. The difference is that it basically boils down into the hardware foundation. So for example, if you look at the software foundations, we both programs take the same courses. Okay, if we look at the hardware foundation, the computer science program takes only digital logic and computer organization. So they don't take electronic circuits fundamentals, they don't take embedded systems, they don't take the design and modeling of digital systems. So these three courses in the hardware design, they don't take. If you look at the networking and security, they don't take the data communication. So they don't learn about the fundamentals of signal transmission and transmission media and all this. They just take a course in computer network and computer security. So if you look at what computer science students lack, the data communication course, they lack the embedded systems, the digital system design course, and the electronic circuit fundamentals. So they lack the hardware, like more knowledge about hardware design, and they lack the data communication fundamentals. Now, what they take, on the other hand, okay, they take database design, I think web development, and I think analysis of algorithms, these courses, and they take an AI course. Now, I think the AI course they take, it overlaps heavily with the AI course that we offer as part of this, and I'm not sure really how different or how they will make that course different. So I believe now the AI advantage is lost because now all students take the data science and AI. So in fact, the AI course that we offer, which is CO292, is the prerequisite for the concentration. So you can go and specialize in AI concentration with CO292. So you don't need to take another course on AI to do that. So if you look at it, who has the advantage? In my opinion, yeah, I'm biased, of course, as a chairman of the computer engineering department and as a graduate of the computer engineering department. I believe that the computer engineers are better positioned. I agree that database is important. When I was a student, I took it as an extra course, in fact, and you can learn it like on your own. Web development, again, it's very easy skill that you could learn it yourself. But if you look at computer science students, if we look at security, for example, okay, there are lots of attacks that happen at the hardware level. Now, they are not having that aspect. They have like weakness in that aspect. So they will not be knowledgeable much about hardware attacks and so on. While computer engineer, they will have more knowledge about hardware. So they understand hardware attacks, they can deal with them. They're also familiar with software, so they can deal with software attacks. So they have more knowledge about networking. So they are more like positioned for like to be more knowledgeable in cybersecurity than computer science. And also the data communication course here, it covers like some foundations of signals and systems that one needs to understand more. For example, the area of signal processing or computer vision and so on, which computer science don't have. For example, when I did my master degree, I did it on image compression. And the knowledge I took in that course, data communication, helped me to basically do my master in image compression and understand image processing because I had some foundation about signals and systems, which computer science don't have. So I believe, okay, with the large overlap between the two programs, that computer engineering students are more equipped and more ready, and they have stronger foundation.
There is a question from a group of senior students asking about the capstone or senior project. What is the new, if you can elaborate more about the approach, or if they can work on a team of only CE students, or
okay.
We have Dr. Rabah here.
Yeah, Dr. Rabah, I'll just talk briefly, and maybe Dr. Rabah can add more about it. And as you know, the university has, since actually 2 years, more emphasis has been on multidisciplinary work. If you look at these concentrations that were created, or the professional master programs, in fact, from the beginning, we designed them to open them not only for one major. Like we wanted students from multiple majors to be enrolled and work together. Yani مثلا IoT, we have students from electrical engineering, students from computer engineering, students from computer science. It hasn't been opened yet for computer science because they needed the circuits background, but inshallah in future, they need to take this electronic circuit background, they can join. Now, we want students from different background, robotics, for example, students maybe computer engineering, electrical engineering, mechanical control, and so on. The idea is to encourage like multidisciplinary work. So now additional step has been done this year where senior projects is experimented with some majors so that it will be multidisciplinary, where students from different majors will work on a senior project. Again, to get like better outcome of this senior project experience that the students do. So we pick a problem from the industry, build a team of the problem by nature should be multidisciplinary, build a team from different majors and try to come up with a solution. This is the intention. I mean, this is the first trial. There might be some hiccups here and there and so on, but we hope that eventually, inshallah, that this will become successful and it will eventually be applied across the whole university. This semester, we're applying it for few majors. We decided to participate because we thought that this could be an enriching experience for our students. Dr. Rabah, maybe you can add more.
Assalamu alaikum. So the short answer, no, you cannot have a group of all CO students. And as Dr. Ayman mentioned, it's multidisciplinary. So by definition, each senior design project group should have at least 2 disciplines or 3. Minimum is 2. But 2 things to notice. First of all, the groups are usually 4 to 5 students. So you might have like 2 or 3 CO students and 1 masalan or 2 mechanical engineering and so on. So you will still be working, you could still be working with CO students. It's just that you have also other disciplines to work with. I don't know if that's clear but a group like 4 or 5 CO students alone is not allowed under this new system anyway. So right now we have, for example, we have about 20 CO students. They are distributed over about 14 groups. In total, we have 21 groups. It's 4 departments participating. So we have some groups with 3 CO students, some groups with 2 CO students, some groups with 1 CO student.
Dr. Muhammad, is the conducting a project is the same as the old way, or there is a difference also in picking the problem?
Actually, the way they are running the projects is very similar to CO 300. Our students are finding the process very comfortable or very familiar. Okay. They're doing many things that we teach our students in CO 300. Okay. But again, due to the multidisciplinary, things are a little bit different, but every department is represented with a coordinator. So I'm representing the COE, and we make sure that every student in every group satisfies the requirements of his mother department. So CO students, they need to do COE work. So he will not join another group and be doing something that is not related to his field. So they get, from that point of view, it's very similar to what they used to do in the COE department. They get to do the same type of work. They're not going to do mechanical engineering or civil engineering work. No, they're still going to do the same thing they used to do here, designing embedded systems, setting up networks, setting up, distributed applications in the cloud or mobile phones and things like that. It's just now that they are part of a bigger team, slightly bigger team with, other disciplines involved.
Okay. Thank you, Dr. Muhammad. Presentation, the presentation that Dr. Ayman used is in the chat, so if you want to download it. We still have 5 more minutes, so if anyone has anything to say or any question, I just want to emphasize something that inshallah this is not going to be our last meeting. Inshallah, we're going to have some meetings inshallah in the future. The department is planning to hold some seminars with people from the industry to talk about their technical stuff that they or the technical things about COE or their jobs and how they are related to what did they do in the job market. Also, the department is planning to hold some or arrange some visits to some companies, Aramco or other companies, maybe also Google. We will try actually to arrange a visit to Google اسمه data center here اللي هو حق الكلاود data center. We hope that we can do it in ايش اسمه this semester or during this year. So this is actually our plan in the department, and these visits will be exclusive for CUE students. So only CUE students can can attend these visits. We have 4 more minutes, inshallah. So if you allow me, I would like to thank you all for coming. I would like to thank Dr. Ayman for his for allocating some time to do this presentation and attend this meeting. And also I would like to thank all my colleagues, دكاترة القسم. We have more than 10 faculty, almost 15 in the meeting. So I would like to thank you all for coming, and we can actually conclude our meeting right now. Thank you all, and تصبحون على خير.
Okay, let me just add one final note. I would like to emphasize that we are here, inshallah, to serve you. You are our students, and we would like to that you have an enjoyable and fruitful learning experience while you are at the department KFBM. So do not hesitate to reach to any of us whenever you have questions or you have anything. You can reach me through email using MS Teams. And inshallah, I'll respond to you quickly as soon as I hear from you. So we'll be happy to hear your suggestions, like how we can improve. My door is open for you. Don't hesitate, just come and provide, and we'll do our best, inshallah, to improve whatever aspect we are doing, inshallah.
Thank you all. تصبحون على خير إن شاء الله.
السلام عليكم.